Hi, I'm gonna show how I built this Minecraft copycat using React and React Refiver. Uh, yeah, let's start. Like in many other React projects, I decided to use the Create React framework in order to create the boilerplate code for this app. I immediately went ahead and deleted all the stock code that the Create React app starts with, and I made sure that everything was working and rendering in the local host. Next, I went ahead and installed React Refiver and Three.js and followed up the basic installation tutorial in order to render two cubes in the canvas. I immediately had to write some CSS in the body of the HTML of the main app in order to make the canvas show us a full screen. So I installed Sass and wrote simple CSS in order to accomplish that. At this point we had a beautiful cube rendering in the center of the screen without no texture, so next step was to add a texture to the cube. Now, since at the beginning I had planned to add many textures and add many different cubes to the project, I decided to go with an implementation very similar to how Minecraft handled textures. That is loading a texture sheet and then mapping each texture to a different material, and then applying the material to the cube. So it actually got more complicated than I thought it would be, so I decided to just load each texture from its own file, then apply them to the respective face of the cube. In order to do that, I actually had to look online for a while in order to get the original Minecraft textures in an individual file, and then I actually got into the Minecraft wiki and realized that actually Minecraft stopped using the previous method, which had all the textures in just one JPEG image, and now they actually had the individual JPEGs for each texture on its own file. So what I did is I went into the Minecraft game files and extracted the game information. The textures were all there, so I copied that into the project, and voila, now I had all the texture I needed in order to make the cubes look like they came from Minecraft. After that, it was just a matter of applying each texture to each respective face of the cube. It was actually very easy because it turns out that the basic material from Three.js can accept an array of textures and then map that to the predetermined face of the box geometry. I created a object which had an array of textures, and I will load those textures using the Three.js loader and then apply the textures to the corresponding face of the box geometry. So that's how I got the basic grass cube. Now, I did face a particular issue with the top grass texture, and it is that the original Minecraft files have a gray texture, so it can be graded depending on the biome that the grass block is placed on. That was a very easy fix. I just loaded into GIMP and multiplied the gray texture with the plains green biome texture. So at this point we had our main asset, which was the Minecraft grass cube. I went to Trello and added a few tasks for declaring the scope of the project. One of the tasks was to add a blue sky. That was pretty easy. I just had to change the color of the background of the canvas to sky blue, and voila, I had a sky. That was the easiest task. For the first prototype of the terrain, I actually went a very easy route. I created an array. I assigned a position to each block based on the position in the array. So I ended up with a n by n grid of blocks. Now, for the actual procedural generation part of the terrain, I wanted to use an algorithm called wave function collapse, which I was really excited to actually explore and use on this project. Sadly, I got into the conclusion that using this algorithm will have been too complicated for the scope of this small project. I'm still very excited to build something using the wave function collapse, but I will have to leave that for later. So I went ahead and used the old and reliable Perling noise map solution. Basically, what it does is it generates a noise map, which is an image which has a few pixels in the grayscale. So depending on how dark or white they are, we can map that into the position, in the Y position of the blocks. So basically a white pixel will be the highest one, and a black pixel will be the lowest one, and then the grays will be in the in-between. Luckily, I found an NPM library called NoiseMap, and it implemented a few noise algorithms. One of them was the Perling noise, so I used this in order to create a Perling noised image that I could load into a canvas and then iterate in the canvas, reading each data of each pixel, checking whether it was on the grayscale or the position of the pixel, in order to know where and which height was the block located at. Now that the sky was blue, the grass was green, and the terrain was getting generated, it was time to add a first-person camera. So I haven't mentioned this, but I have been using a library called React Tray, which is a library with a bunch of components that help while using React and 3JS. One of the components that this library facilitates are the camera controllers. So there is actually one of the controllers which is called a cursor lock controller, which basically allows you to lock the cursor to the camera and also makes it invisible. I believe that you cannot see it becoming invisible in the video, but when you use the browser it does become invisible. So basically this is a first person, it has a first person behavior, and the only thing is that the camera doesn't move, so you can only use it to look around. So in order to implement movement into the controller, I created a component which returned the pointer lock controls, and that component had a use frame hook from React 3.5, and inside of that what I did was I took the camera position, and if the user was pressing the W button, which is the going forward button, then I will add a scaled vector that didn't scale in the Y direction, so you could only move in the X and Z directions, so there was no upward or downward movement. And yeah, this is basically how the movement worked at the beginning. I did actually wanted the user to be able to walk up and down if there was a block in a different level. So I accomplished this by casting a ray downward in the downwards direction from the camera and checking for the position of the direct block that was below the user. So I will take that position and then set the camera into that vector and add an arbitrary variable which will dictate the Y position of the camera based on the cube below. Well, now the basics of the project were almost done, but I was getting a little bit tired of working on this, so I decided to cut the scope of the project. I really wanted to get into editing the video, so I decided to add just one last feature, and it was the ability to remove blocks. So I actually took the lazy approach. I used the synthetic events from React in order to check whenever the user clicked on a block, and if the user had clicked on a block, it will basically self-destruct, like it will get removed from the rendering from Three.js. And basically that's how it works. It worked just fine. Like, it was a little bit buggy, but at this point everything was buggy. And yeah, that's basically how I did Minecraft in React. I'll make sure to leave the link for the public repository in GitHub down the description, so you can check everything I did. I know I probably didn't do the best job explaining it on this video, but you can just check the files and like see how everything is laid out. Thanks for watching. It's really late, it's like 4 AM right now, and I'm just finishing like editing this, so if you liked it, please I don't know, follow me on Twitter or something. See ya.